For decades, we believed black holes were simple. They were cosmic traps, gravity wells so powerful that nothing, not even light, could escape. They were the ultimate end, the final destination for anything unfortunate enough to cross their path. But recent discoveries suggest something far more unsettling. Black holes may not destroy reality. They may preserve it. And if that's true, then nothing in this universe ever truly disappears. Not stars, not matter, not information. And that changes everything. Let's start with what we thought we knew. A black hole forms when a massive star collapses under its own gravity. The core compresses inward, crushing itself into an impossibly dense point. Space itself folds. Around this collapsed core forms the event horizon, the boundary of no return. Cross it, and escape becomes physically impossible. Inside lies the singularity, a region where density becomes infinite, and our laws of physics stop making sense. For decades, scientists assumed that anything crossing the event horizon was lost forever, destroyed, erased from existence. But there's a problem with that idea. In physics, information cannot be destroyed. This isn't philosophy. It's a fundamental rule of quantum mechanics. If you burn a book, the words aren't destroyed. They're scrambled into ash, heat, and particles. The information still exists, just rearranged. But black holes seem to break this rule. If matter falls in and disappears completely, where does its information go? If it's destroyed, then the foundations of physics collapse. This contradiction became known as the black hole information paradox, and for decades, it haunted physicists. Then, in the 1970s, Stephen Hawking made a discovery that complicated everything. Black holes are not completely black. Because of quantum effects near the event horizon, they slowly emit radiation. This radiation, now called Hawking radiation, means black holes gradually evaporate over immense timescales. Eventually, they disappear. And here's where it gets terrifying. If a black hole evaporates, and the information inside it was destroyed, then that information is gone forever, which violates quantum mechanics. So either quantum theory is wrong, or black holes don't destroy information after all. Recent theoretical breakthroughs suggest the second option is true. Information may not be destroyed inside black holes. It may be stored, encoded, preserved on the surface of the event horizon itself. This idea is part of something called the holographic principle. The concept suggests that everything inside a region of space can be described by information stored on its boundary. In other words, reality may function like a hologram, three-dimensional information encoded on a two-dimensional surface. If that's true, then black holes are not cosmic shredders. They are cosmic hard drives. Everything that falls into a black hole might be compressed and written onto its surface, not erased, not annihilated, but transformed. Which leads to an unsettling implication. Nothing truly disappears. When a star collapses into a black hole, its information is preserved. When matter falls in, it leaves a trace. Even when the black hole eventually evaporates, the information may slowly leak back out into the universe. Scrambled, but intact. This means the universe keeps a record of everything, forever. And that challenges our deepest intuitions about destruction and endings. We've always imagined black holes as the ultimate point of no return, the end of the line, the place where reality breaks. But what if they are not endings at all? What if they are transitions? Consider this. If information is never destroyed, then every event that has ever occurred still exists in some encoded form. Every explosion, every collapse, every particle interaction, the universe does not forget, it reorganizes. Some physicists now argue that space-time itself may emerge from information. That reality is not built from matter at its deepest level, but from data. If black holes encode information holographically, then perhaps the entire universe operates the same way. Our three-dimensional world might be a projection of deeper informational structures, which means black holes aren't anomalies, they're clues. Clues that reality is stranger than we imagined. And here's the most unsettling part. If information is fundamental and never destroyed, then nothing truly vanishes, not even time, not even the past. The universe becomes less like a machine and more like a memory. Every star that ever burned, every galaxy that ever collided, every moment that ever happened, encoded somewhere in the structure of reality. Black holes were once thought to be the ultimate destroyers, but they may be something else entirely. Guardians of information, archives of cosmic history, and if they preserve information instead of destroying it, then the universe is not slowly fading into oblivion. It is storing everything, which means the end of something may never truly be the end. Black holes were supposed to mark where physics breaks. Instead, they may reveal that reality is deeper and more unsettling than we ever imagined. They are not just objects in space, they are questions. And the answers they're forcing us to confront may change how we understand existence itself. Because if information is never destroyed, then nothing is ever truly lost. And that might be the most terrifying discovery of all.